There's one more thing I want to talk about when we're looking at differentiating ln of x. And this is something that might seem a little bit weird because we're going to pull in an absolute value and look at some domains. But this is going to be important for later on in calculus when you're looking at integrals and antiderivatives. So it's important that we take a quick look at it now. Now, we just looked at taking the derivative of f of x equals ln of x. But this is a function whose domain is only the positive numbers, right? We know the domain here is just the positive numbers, so the interval from 0 to infinity. But if we look at the derivative, we saw that the derivative was 1 over x, and the domain of that function does include all the positive numbers, but it also includes the negative numbers. So we have an interesting situation where we started with a function that was only defined for the positive numbers, but the derivative also happens to be defined for the negative numbers. Now, if we're looking at the derivative as the rate of change, or we're looking at it as the slope of the tangent lines, of course, we would only look on the domain of the original function. It wouldn't make sense to think about the derivative on a domain that has nothing to do with the original function. But we can actually do an interesting thing to this original function to expand the domain to include the negative numbers in a way that allows the derivative to still be 1 over x. Let's take a look at f of x equals ln of the absolute value of x. All right? Putting x inside absolute value symbols allows us to consider negative numbers for x, because when you plug in a negative number and you take the absolute value, that gives you a positive number, and we can take the log of a positive number. So in this case, we have expanded the domain into the negative numbers as well. So we've got negative infinity to 0, union 0 to infinity. All right, still not defined at 0, because even with those absolute values, if we take the absolute value of 0, still gives us 0, and the logarithmic function is only defined for positives, not 0. So we still have a break in our domain at 0, but I'm going to claim that if we differentiate this function, we're still going to end up with 1 over x. Now, this is a little bit more complicated because it acts differently when x is positive or x is negative. So I want to look at this as a piecewise defined function. Instead of having the absolute value, I want to break it up into the two parts of the domain. So in this case, f of x, we can look at it in two different ways. If the domain, if we're looking at positive numbers, x is greater than 0. If x is greater than 0, then the absolute value symbols here don't do anything because we've already got a positive number. And so ln of the absolute value of x is really just the same as ln of x, right? For the positive values of x, putting those absolute value signs doesn't do anything. It doesn't change anything. But if we're looking at negative values of x is less than 0, when we have a negative number in here, the absolute values turn it into a positive number, and effectively they take the opposite of whatever that x value is. So the function actually acts like ln of the opposite of x, right? If we're looking at negative numbers for x, we know that the absolute value symbols turn that into a positive, and so when x is a negative number, we can put an opposite sign out front, a negative sign out front, and that turns the negative value into the positive value that we need for the logarithm. So we can consider ln of the absolute value of x as a piecewise defined function that's equal to ln of x for the positive values of x and ln of the opposite of x for the negatives. And doing this allows us to differentiate it piecewise. We can differentiate each of those two functions on the different domains. Now we know that the derivative of ln of x is 1 over x. We've already seen that. So on this domain, when x is greater than 0, the derivative is still going to be 1 over x. Let's take a look at the domain when x is less than 0. We've got to differentiate ln of the opposite of x, and we can use the chain rule there. The derivative of ln of u is 1 over u, so that's 1 over the opposite of x. But we have to multiply by the derivative of the inside. The derivative of negative x is negative 1. And so we've got, this is a multiplication sign in the middle. We've got two negatives that cancel and turn into a positive. And so this becomes 1 over x if x is less than 0. And so it turns out that it doesn't matter which part of the domain we're looking at, the derivative ends up being 1 over x, whether we're looking at the positive or the negative bits. And so what we can say here is that in general, the derivative of ln of the absolute value of x is equal to 1 over x. This is more general than the rule we learned at the beginning of this lesson that just said the derivative of ln of x was 1 over x, because ln of x is only defined for positive numbers, but this expands it and allows it to be defined for negative numbers. You might be absolutely confused about why we're doing this, and I just want to give you a little bit of a glimpse into the future. We are looking at derivatives now, but later we want to look at antiderivatives, which is basically saying if we're given a function and we're told it's the derivative of something, we need to figure out what function that derivative came from. And so if we are given 1 over x, and that's the derivative of something, we know that the antiderivative, or the function that derivative came from, it's not just going to be ln of x, because that's only valid on half of the domain. It's going to be ln of the absolute value of x. So this is not something that you really have to worry about right now. We're probably not going to differentiate ln of the absolute value of x that often. Most of the problems we're going to do are just going to be ln of x or some composition of functions with ln of x. But I want to show you this now so that later when we're looking at antiderivatives and we want to know where does 1 over x come from as a derivative, it comes from ln of the absolute value of x, not just ln of x.